Hello. Thanks for coming back. In the last lesson, you'll recall that we obtained data from the NOAA Digital Coast Data Access Viewer tool. In this lesson, we'll take a look at taking that data and getting it ready for use within Revit. This data needs to be optimized for Revit in order to have a successful experience inside Revit with AutoCAD data. Because of this, we want to start in AutoCAD, not Revit. So if you switch over to AutoCAD 2016, the first screen that you'll be presented with is your Start screen. And you'll want to click the Sign In button and sign into your Autodesk 360 account. This will allow us to get aerial imagery embedded within our AutoCAD file. Once you've signed in, you'll want to open the Start drawing, the 00 Start file. This drawing allows us to take our NOAA data and bring it in. One of the first things that you'll want to do is you'll want to set a variable called INS units. You're going to want to set this to a value of 0. You'll get a warning about photometric lights not working, but that's okay because we're not rendering within AutoCAD. Setting it to 0 is a unitless value. The DXF file that we get and the aerial imagery that we get will come into this drawing at the proper scale with it set to 0. Go ahead and start the Insert command. I prefer to type the letter I and hit Enter. And browse for your data that you received from NOAA. I've gone ahead and renamed mine to Contours Source. And you may also need to set your file of type to DXF. You'll want to leave the values for insertion point, scale, and rotation at their default locations. This is because the data that's being imported from NOAA is located in a geographically correct location. And by using 00, it makes it insert so that the 00 of our data is equal to AutoCAD 00, which is also the coordinate point for our state plane coordinate system. Now, you'll want to hit letter Z, enter, letter E, enter to zoom extents, or double-click the wheel on your mouse. That will allow us to see our data because it's many thousands of feet away from 00. What we're left with is our DXF contour data. Now when we select this, it's still a block. So you would want to explode it. I prefer to type the letter X and hit Enter. That explodes it down to its base objects, or so one would think. If you inspect some of this other information by going to your Properties palette, you'll notice that we still have block references. So what you'll end up wanting to do is you're going to want to select everything and explode. After exploding, you'll notice that if we zoom extents, our data seems to disappear. Really, our data is not gone, it's just really small up here in the upper right corner. And over at the bottom left corner of our screen, if we do a crossing window and look at properties, you'll notice that an attribute definition is selected. We'll go ahead and delete those attribute definitions and then zoom extents again, and we'll be back to our data. Now, when we're looking at our data, if we select things, we should get lots of grips. That's the little blue squares. When you select an object, those are what we call grips. And those grips are what we want to make sure that we have. If you were to select one of these lines and inspect properties, you'll notice that it has information shown at a negative elevation. And if you were to select another line, it's got a different negative elevation. And that's because this content is actually stored at its correct Z elevation or vertical elevation. Now, the next thing that we're going to want to do, now that we've got our DXF information in here, is we want to import aerial imagery. Now, because we're still in the conceptual stage, we don't have high quality aerial imagery at our disposal just yet. So we're going to use a built-in tool within AutoCAD. It's called geolocation. And when we do this command, geographic location, we're going to choose to use map information. And this is why we had you sign into your Autodesk 360 account. By signing into your Autodesk 360 account, it allows us to display this information within AutoCAD. You'll want to start by typing in your city in the search box. San Clemente, California. That'll zoom you into the city, and you just left click to pan, left click and drag to pan into the pier. And you're going to want to zoom in all the way to the base of the pier where it ties into the beach. And you'll notice that there are these red areas. What this is a ramp going down below the train tracks that go along the beach. And as you're looking at this, if you right click, you can choose to drop a marker on the image. Now, once it's dropped, if you press and drag on the red part of the pin, you're going to want to move it so the pointy portion of the pin is about as close as you can visually get to the corner of that tunnel. The next thing that we'll do is click Next and look for our correct state plane coordinate system, which is California 83, NAD 83, foot. And you'll notice that it's deciding to bring it in at feet, which is correct. When you click Next, you need to do two more things. First, you'll notice that there's this kind of double lobe feature on the beach, which corresponds to the ramp going down for the tunnel. And we're going to pick an endpoint location. This is mirroring the pin that we put on the map here within AutoCAD. So we'll click on the endpoint there and then hit Enter to finish the command. And you'll notice that it displays map information behind our contour lines. And this is great because now what we have is contour lines overlaid on top of aerial imagery. And if you look, there's a ravine over to the right, and the contour line should match pretty closely to the location of that ravine. Contour lines should match relatively closely to streets that go along here. And so what this is doing, in addition to giving us graphical data, is it also allows us to confirm that our information is in the correct location as close as we can get to the real world. So hopefully this helps you see a couple ways to bring in data from the NOAA Data Access Viewer and get it into workable data within AutoCAD, as well as being able to bring in a geographic aerial image that's georeferenced to its real world coordinates. Thanks for watching, and stay tuned for the next one.